Hi everybody, my name is Mutuana. So let's get started. So we have a question right here. So the question say, let me just drag this aside because we don't need this calculator. This calculator must stay aside a little bit so we can get started and solve our question about uh uh the friction in a roller coaster in the car going down to the inclination. This is a way easy question, okay? So now they say here in equation, let's get started. Like I said, my name is Mutuana Wabantu. This question comes from student from South Africa, okay? Especially from KwaZulu-Natal, Johannesburg, Gauteng, and Western Cape. So if you got question, always let me know so I can say shout out to you. So this question say a roller coaster, okay? Car. Oh, so what does that mean? So this car here, roller coaster, go down to the inclination. But let's read. Let's read. Reading is very, very important. So this car has a mass. We have a mass of a car, okay, with the engine switched off. So they switch off the engine and they say, you know what? Let's see what's gonna happen. Let it go. It started to go down now. But I don't think it's gonna win going up because it just went in the corner. You see, speed it was 4, and then now it went to 2 meters per second square. Means the speed had to decrease. So I don't think space on this car is gonna go all the way to the top. So maybe you have to switch on engine now. But let's read and see what they have to say. So, and then they say, as shown in this diagram below, at point A, 10 meter means 10 meter where the car was off, and then is above the ground. The speed of a car is 4 meter per second, just like how they say it's 4 meter per second. Everything they show in the diagram is what they say. Okay, at point B means this car went all the way to B. The speed increased, but here we don't know the height, how long it is from the ground to that one right there. But they mention something here. The motion of A to B, during the motion, see how did I say here? During the motion, read careful here. So during the motion from A to B, we have this energy to overcome the friction. Okay, so there's an energy involved here because remember there's a friction force in the surface. You know, friction force means if this object moves this way, friction force always oppose, means it's always against the motion. If this car moves this way, friction force is going to go opposite direction. So to overcome that friction, there's an energy which were used to overcome friction, which is this energy. What is the question? Let's start with the first question. They say define the non-consecutive force. Okay, look. So look, a non-consecutive force, right? This is the force is non-consecutive if the weight of an object depend on the path taken. See, the weight of this an object depend on this path taken, and we can see this object was depending on this path it took from A to B, and then probably might go to C. So we can just simply say the weight is not is okay. The force is now it's not weight. Come on, the force is non-consecutive. Okay, if the work it does if the work it does on an object it does an object depend on the path taken, depend on this path which is took, depend on the path taken. Oh wow, so that's it. Oh yeah, but there's a lot of definition, brother and sister. What you can do, you can just go to the books, you can use social platform, or you can use Google, or you can use any source of where you can get the easy definition that's going to more easy for you to understand or to memorize. So that one is clear, understandable. Let's go to the question number 2. So question number 2, they say here, look, okay, how could they change in kinetic energy after a car has traveled from A to B? Changing kinetic energy. Come on, family. What is kinetic energy? Kinetic energy, look, whenever there's a motion of an object, then the kinetic energy will involve. What does that mean? Look, okay, look. So we say, look, look, okay? Now, let's say, calculate changing. So kinetic energy equal to a half times mass times velocity square. What does that mean? For example, if you have inclination like this, let's assume. Okay, now let's assume there's a car here. This car when it started here, let's say, let's assume it was at rest, means 0 meter per second. It was at rest, means at rest, meaning it's not moving. So our velocity equal to 0. Velocity initial equal to 0. And now it drive all the way to the top, so to the top. When it reach here, velocity final equal to, let's say, 100. We just assume. See? So we want to find the kinetic energy. Changing kinetic energy is easy. What we want to say, okay, changing kinetic energy. Kinetic energy final minus kinetic energy initial. So what does that mean? That means we say kinetic energy equal to a half times mass. Mass is going to be the same. If I'm going to be here, I'm going to be there on top. The mass of the car, the weight of the car is going to be the same. So kinetic energy final means you're going to say a half times mass times velocity final means velocity that's here, but a velocity must be square. Whenever there's a velocity in kinetic energy, you must square that velocity. Minus a half, and then we say mass velocity initial square. You see what I'm saying? Okay. So now we want to find the change in kinetic energy, and then we say, look, a half m and a half m are the same. Means I'm going to say a half mass. I'll factor out, and then I'll be left with the velocity final minus velocity initial square. So what we can do now, we can simply simplify by substituting the value. Our velocity final, do we have 100? So velocity final is going to be 100, and mass. Okay, let's say the car has a. We just assume. Let's say the car has a 500 kilogram. Man, that car must be very light. So we will say now this same is say a half times mass. Mass equal to 500 kilogram times velocity final equal to 100 square minus velocity initial. It was at rest. So velocity initial equal to 0 square. So we can simply plug in a calculator. This is going to give you a final answer, right? So this is going to be changing kinetic energy equal to whatever we're going to have here in the calculator. And then don't forget to say your joule, because that's a unit of kinetic energy. So now we're going to play the same game here. Easy game. Play a game. Easy game, like we say. What? Easy game. Let's say it together. Easy game. Yeah, I love this. Okay. You guys have no idea, man. I like this kinetic energy, you know. It's like, you know, I just feel like I just gained kinetic energy. It means I just gained that velocity. It means I'm moving. So now we're going to say here, okay, we're going to say now, calculate the changing kinetic energy of A to B means finals B. So we're going to say changing kinetic energy equal to kinetic energy final, or we can say kinetic energy at B minus kinetic energy initial, which is kinetic energy at A. So this may say kinetic energy, what is the final? Final at B minus kinetic energy initial means at A. So we can simply plug this in the calculator, changing kinetic energy equal to kinetic energy at B. What is at B? At B, okay, so we know kinetic energy is a half times mass times what? Velocity at B square means that's it for final, because final is at B for now, because they say A to B minus a half minus the initial at A. So we can plug it in. But before you plug it in, we see these are common. We have to take the common out. A half m is common. So I can simply say a half mass, but velocity final at B is not the same. These and these are different. So you say velocity at B minus velocity at A square. So then let's plug it in. So we can plug it in easily like this. Okay, a half. Okay, a half mass. Mass we know equal to 200 kilogram. 200 kilogram. Okay, velocity final equal to 2. Velocity initial equal to 4. So plug this in the calculator, and if you plug in the calculator, this is gonna give you our change kinetic energy equal to negative 1,200 joule. Okay, excuse me. So we have a change in kinetic energy equal to negative 1,200. So we can just say, okay, our change in kinetic energy we know equal to negative 1,200 joule. See, that's our change in kinetic energy. But look, man, I just feel like I just gained some kinetic energy because you know what? I just gained more motion, more energy. See? So I love this. I mean kinetic energy because I just gained some momentum now, some motion and moving the velocity. Okay? So look here. Another thing. You can change this to kilojoule if you want because we know anything which is more than 1,000, you change it to kilojoule. How do you change to kilojoule? You divide it by 1,000. Only if it's more than 1,000. And we see this more than 1,000. Divided by 1,000 is going to give us negative 1.2 what? Kilojoule. Just like a kilogram. It's not good to say 1,500 gram. Is that good? No, it's not good to say 1,500 gram. Meaning I can change it to kilogram by divided by 1,000 and divided by 1,000 is going to be 1.5 what? Kilogram. So same with the joule and kilogram and watt. You play the same similar game. So we have changing kinetic energy. Now let's go to the next one. So for the next one, they say here, use the energy principle to calculate the height. But before we go further, Tammy, look, if you first time here, come here, show me some love, man, because I know some of you here, you might be new, okay? So come here, subscribe here. So every time you don't miss the notification, come to China Wabantu Academy, subscribe over there. Okay, now let's continue here. So they say here, find the height. Okay, height what? Height. See? But we have to use what? Energy principle. Now let me take you back a little bit, right? So in the energy principle, look, there's a lot of formula. So they might give you formula sheet. If they don't give you, you have to know this, right? So I'm going to use this formula here. Okay, which say what? Work done equal to change in kinetic energy plus change in potential energy. Why do I say that? Look, face. Okay. What is potential energy? Because I'm coming there. We need to show you what is potential energy. But let's go back to that page. Okay, look. So we're going to say change your work done. Change your work done to get the height. Because look, there's a height involved. So change your work done. No, work done. Change in kinetic energy plus change in potential energy. But what is potential energy? Because we check kinetic energy, but we don't know what is potential energy. Look here. Potential energy always involves height. Whenever there's a height, there is a potential energy. What that mean? Look, if you have, let's say this inclination. Remember, there's no height here. Okay, you standing here, and I'm standing here. Or let's say me, I was here, or you were here. Let me talk about you, so you can maybe understand. So, what's your name? Let's say Sbongile Nkosi. So Sbongile Nkosi, she was here, and then she went all the way to the top in KwaZulu-Natal Hill. Okay. So now, she's saying now, like, hey, Mutwana, I'm here, right here already. So what? Look, if you're here means you have a certain height. Let's say a height equal to 4 meters. Okay, let's say 4 meters. But here there's no height, means equal to 0. So then let's find the potential energy change. So we're going to say potential energy equal to mgh. Mg times height. What does that mean? Means you must have a mass and gravity. Gravity is 9.8 in height. So change in potential energy means you're going to say potential energy final minus potential energy initial. So let's find change in potential energy of Sbongile Nkosi. So change in potential energy equal to potential energy final minus potential energy initial. So what that means we're going to say potential energy final means mgh. But a h, let's say h final minus, this h final, mg h final minus mg h initial. See? So then we can simply say, let's play this. So it's okay, equal to m and g's are common. M and G are common, so we can factor out, and then we're going to left with the H final minus H initial, because we want to get the change. So what is our final? Our final we know equal to 4, but our initial equal to 0 because there's no height here. Initial equal to 0. So we're going to say, what is our M? Our M we know. Okay, so Bonkilen Cos, what is your weight? Muchwana, I'm only 45 kilogram. Okay, so we're going to say how weight equal to 45 kilogram times gravitational force. Our gravitational equal to 9.8 is always constant, you never change. Okay, times bracket height final equal to 4 minus height initial equal to 0 because there's no height here. Height final equal to 4 when she was on top here. So we can subtract, say, 45 times 9.8 times 4. Plug in the calculator, and this is going to give you energy in joule. You put your answer in joule, so this is going to be potential energy. Oh, okay. See? Oh, so now we know, okay, that's how you do if you want to find the change in potential energy. But if they just ask, find the potential energy, we know it's just M times G times height. For example, me here, I'm sitting. Since I'm sitting down, I don't have a potential energy. You know why? Because my weight is... I don't want to change my weight now. I want to be balanced. Okay, let me tell you, my weight... Okay, so my weight... Okay, so my weight is mg height. My potential energy meaning, okay, my weight equal to 89 times gravity. I know, oh, Chwana, you so heavy. I got also muscles. Okay, 9.8. So my weight is 89, but the gravitational force, you know, is 9.8. Is always constant. This gravitation always constant times the height. So since I'm sitting here, right here, I have a chair. You can see means there's no height. From me to the ground, there is no height because I'm touching the ground. Meaning the height is 0. So I don't have a potential energy. So potential energy depends on the height. Now let's go back to our question and solve based on how they ask us to solve. See? So I believe now you understand how that potential energy went. Now we're going to go back. If you go back now to the question, they say, oh, can go the height. But I use the principle of energy. Use the principle of energy. You know what I'm going to say? I'm going to say, look. So I'm going to say here, change the weight down. Change weight down. Or weight down. Because there was a weight down here. So weight down. NC. WNC. That's a weight down. Equal to changing kinetic energy. Plus changing potential energy. So now let's start with the changing kinetic energy. Changing kinetic energy we had already equal to negative 1,200. We know already. So we just want to get what? This, but which they give us because they say here when object moving from A to B, it had this energy which energy was used to overcome the friction. Oh, so we have this energy already? Oh yes, which is what equal to 3.4 times 10.3 joule equal to 3.4 times 10 power negative 3 joule. Okay, and then we say changing kinetic energy. We have 1,000 negative 1,200. So do not take the kilojoule one, right? Especially when you want to do substitution, it must be in joule. So negative joule plus changing potential energy. We know how we can do that. Equal to m g h final minus h initial. But what is h final? H final, remember, is A to B. Means this is going to be final, which is height equal to height minus h initial equal to 10. So I can say instead of say h final, normal h final, you just say height exactly and h initial equal to 10. Or sometime me, I like to do this. You know, I want to get 100 in exam. I say h at, which letter is this? H at is A or B? This is B. Okay, h at B minus h at A. Okay? Okay? So now I'm going to say now, what is h at A? So I can say this equal to 3.4 times 10 power 3 joule plus, because this is going to go over, equal to mass. What is the mass? Our mass equal to 200. The mass is the same. It did not change nothing. Okay, what is the gravitational force? Gravitation 9.8 bracket. Okay, what is the height at B? Just a height. H at A equal 10. So what we can do, we can just make the height this subject, and we're gonna be finished. It's easy like that, fam. You see? So now let's make a subject. So what I'm gonna do now? Look, I'll divide by this throughout. Divide by 200 times 9.8 throughout. And on the left, dot here. So this and this cancel. And then what we're going to do, I'm going to take this negative 10 over, because look, this negative 10 over. So, okay, let's do step by step. So this is going to be, pull all this in the calculator. So here I'm going to be h minus 10. Okay, let's just go step by step. So, oh, I don't know, how did you do that? My God. Okay. 3.4 times 10 power 3 over. Okay, on the right we have what? H minus 10. So what happened here? Look, this h minus 10 is going to go to the left because we want to get the value of h. So for that case, now we're going to finalize by saying, take this to the left. Okay, take to the left. So then we're going to say everything's plus 10 equals height. Okay, see what I'm saying? Okay, so I hope you can see that this is 200 here, right? So, and then plus 10. So now finally we're going to have our height. Put in the calculator, and then it's going to say height equal to 8.8. So our height finally, for this case here, equal to equal to 8.8 meter. And now you have to look if it makes sense. Sometimes you can use a common sense. Look, if this is 10, this is 22, and look, if this 10, look, can this be height? Yeah, it makes sense. It's 8 because if this 10, this is 8, this 22. Look from the ground, look, 10. This look like a lower a little bit. Can be 8.8. Yeah, it makes a lot of sense. But if let's say you get 36, it cannot be, because there's no way this can be 10 and this be 36. And you can see is below. You can see, look, you can measure. Okay, so I think you understand. So now let's go to the last one. Okay, let's go to the last question here and get every marks. We're not gonna leave no marks here, eh? Oh yeah, we get all the marks because we have that kinetic energy, that energy. We have a potential because we on the same height. My potential energy is bigger, okay? Because I'm at the high height. See? Now we go. So we want to go for the last question, but before you do last question, you have to read very careful here, right? They say calculate the power delivered by engine move a car from B to C. So when they reach here, they realize like, oh, now this car moved all the way from the top to there with no engine because the car was switched off according to the information. See? The car was switched off in a roller coaster, switch off. So now here it could not go normal because the speed was decreasing from 4 to 2. So they say, you know what? Switch on the engine. Now let's start to go up now. They start to switch on in order to move up to the inclination at point C, from B to C. So now they say which is 22 above the ground, mean this height here to there is 22 millimeter. While moving from B to C, the car traveled for 15 seconds from B to C, time taken equal to 15 seconds. Time equal to 15 seconds. And another things, they say constant speed of 2. Oh, so the speed, velocity equal to 2 meters per second. -1. Oh, so when they switch on the car means they decided to move with a like look, when the car was 2, they decided to move with a constant speed which equal to 2 meters per second. 2 meters per second. But they say there's a friction force also involved equal to 50 hectonewton. Okay. So while the car was moving up, look, friction force, man, you always not. Like if you move up this way, the friction force always opposite. Friction force. And this is the force of engine. So while the car moving this direction, it accelerates. The friction force always opposing. Now, what do you want? Let's say calculate the power delivered by the engine. Also, that power by engine. So, please, you know what? I'm gonna say power of anything equal to work done over time. So, since for power of engine, let me find the work done by engine. So, I need to get the work done by engine phase. Don't worry about the power for now. See? So let's get the work done by engine. So we're gonna apply the same energy formula that we used prior to get this. So let's go. So we will say here work done. Remember now, it's not gonna be only work done one. Like you remember when it was coming here, it was just a work done. But now there's a work done by engine, because when the car was moving down before, it was just a normal work done, which is NC. But now there's a work done by engine, and there's a work done by friction force. So we got two work done here involved. See what I'm saying? So we're gonna say work done. Let's apply the formula. Work done equal to changing kinetic energy plus changing potential energy. You can use U, you can use PE, whatever you think is PE potential energy. You can use U. I'll tell you potential energy change. Okay. So now let's get each one. But here in a work done here, we have a two work done. Remember, right? So we have a two work done by engine plus work done by friction. W friction. My handwriting. Equal to changing kinetic energy. Oh, okay. Look. So we're going to say changing kinetic energy from B to C. We're going to say, okay, I have mass, velocity at C, velocity at C minus velocity at B, plus, and you know why I do that, because I explained before, because you get it changing kinetic energy, right? Velocity at C minus velocity at B plus potential energy. We got two potential energy at B and C. So we're going to say M, G, H bracket at C minus H at B. Because there's a change in height. Should I say again? Should I break again? Okay, kinetic energy. Look. This and that. See, and how this comes about? Because, man, how did it come about? Look, the kinetic energy like this. Look, changing kinetic energy means I have mass velocity final, which is going to be at what? At C minus I have M at B, where it was started for this case. Velocity square. So it's me, sorry. Mass is the same. Comes velocity at B. Initial. Change means final minus initial. So kinetic, look, a half is going to be the same. Velocity, these are constant. We factor them out, and there's going to be velocity at C square minus velocity at B square. That's how this comes about. Same with the potential energy, similar, but for the potential energy, the only thing which differs what is our potential energy. So it's going to be M, G, H, but it's going to be, the only thing is going to be H at final, which at C minus H at B. You see what I'm saying? So now we say now, let's finish up. So we say now, let's go. So we have most of the information we have. We say we want to find the work done by engine. But the problem here, look, face. Let's start with here. This, okay. Sometimes if the space is very small in exam, you can make sure you explain all your work for you to get marks. They say this stuff is going to move with a constant velocity. Constant velocity, meaning kinetic energy is going to be zero here. Look, why? Look. Let me start step by step so I can have a space here. The change in kinetic energy equal to a half mass. Our mass equal to 200. Velocity final is going to be the same, because constant means when it's on top here, it's going to be 2 square. Don't forget here. So I was wrong here. Must be like this, not like that. I was wrong. Sorry. I'm sorry. It's supposed to be like this. Okay? That's how it's supposed to be. Okay? Velocity at B. What is velocity at B? Is 2 also. You know why? Because they say move from B to C with a constant velocity. Means constant means it does not change. It's steady. It's the same. So 2 square equal to 4. 2 square equal to 4. So 4 minus 4 equal to 0. So it is 0. 0 times 200 equal to 0 times a half equal to 0. So we don't have a kinetic energy here, because the velocity was the same. So kinetic energy equal to 0 plus, okay, mass equal to 200 times gravitation 9.8 times height at C. Height at C equal to 22. And height at here we have at B equal to 8.88. We had it already here. The height 8.88. We had already 8.88. Now equal to work done by engine plus work done by friction equal to. So now we can just say you can plug this in calculator, so I don't need this 0. I can just say 0 I don't need now, but you can show you in exam, so I don't need 0 anymore. So I can just say equal to that. So the problem here, I need to get what? Work done by friction. How are we going to get work done by friction? It's easy. We almost finished. Now look, if you have inclination, no, before we do that, let's go to the trigger a little bit. Come on, because this is more of the trigger. Look, if you have a trigger Cartesian plane like this, which angle this? This is 0. But when you here is 180. Do you agree with me? So now, because this is the opposite of that, so the opposite is what? 180. That side is 0. 180, 0. So now we say, now let's come back here to the business. What is a work done? A work done on anything equal to force times displacement times cos of angle. That's how you get the work done on anything. Displacement means the distance in a certain specified direction. So now, for now, we want to get the work done by friction. So it's not normal work done, it's the work done by friction. So it's going to be work done by friction. It's just not normal force, it's going to be force of friction for this case, because the work done by friction, force of friction, FF, times distance moved by that friction, times what? Cos of angle. So for that case, now if somebody give you, for example, let's say you have something like this. The object is moving, let's say up. So what the friction acting? Friction is going to be acting this way. So any distance this object is going to move is going to be the same distance this is going to move with the friction. Like look, if you start to drive from here, you say, you know what? I want to go to Josini, KwaZulu-Natal. Or I want to go to Nkandla, KwaZulu-Natal. See? Or Matatiela. So meaning the distance, if I drive, means the distance the force is going to take means my tire or engine force is going to use in the same distance the friction force is going to be covered. What is the friction force? Means the tire, you remember the tire is going to get finished because you drive on a road. So it's going to be friction force between the tire and the tire and the surface on a tarmac road. So the distance that the engine force is going to cover from where you start, see, to where you finish your journey is going to be the same. It cover the friction force, because everywhere you're going to be traveling is going to be friction force on your tire. So for that case now, I'm going to say now, this stuff, remember, is moving up here, from here to there. So meaning, if it's moving up, this side is 0 degree. So anything opposing is going to be 180 degree, because opposing. And for now, we deal with the friction force, and friction force is opposing. So we're going to say now, work done by friction, we deal with the friction equal to force of friction, which is 50. Because they say here, friction force equal to 50. The friction force equal to 50. So equal to 50 times, do you know x distance? No, we don't know x distance, because how it's going to cover here. But we can get the x distance. It's easy. How are you going to get there? Look, we learn from lower grade. We say velocity equal distance over time. But remember, I have a velocity from here to there, and I have a time. So I can make the x the suffix. X distance equal to velocity, which I had to give to me. What is my velocity? Equal to 15. Somewhere here is given. No, velocity equal to 2, and the time equal to 15. So I'm going to say equal to distance equal to v times t. V times t, because I can just simply cross multiplication. V times t equal to x. X times 1 equal to x. V times t equal to v times t. So for that case, this equal to, what is a v? Our velocity will say equal to 2, because it's going to be, and then how long is it going to take? How long is gonna take? They give us here time. How long, man? Let's read here. Sometime 15 seconds. So 2 times 15 seconds. So that's gonna give us distance of the friction force. Okay. So we're gonna say equal to Vt. Yes. So say okay, friction force we got times what? Instead of say x, we can say velocity times time cos. Which angle? 180, because we say this is 0, but this is opposing, it's going to be 180. See what I'm saying? So I can say equal to 180. So I can plug everything. What is a friction force? Our friction force means it's moving the opposite. Our friction force equal to 50 times velocity. What is our velocity? 2 times 15. It's just a 2 times time, 15 times cos of angle. What is the angle? Cos of angle to cos of 180 equal to negative 1. And you can plug in the calculator that one, which say 20. Calculator is easy, man. Plug this in a calculator quick. So this is going to be, same as say 50, 50, 50, 50, and then we'll multiply by 2, multiply by 15, I love this, multiply by cos 180. Hey, negative 1,500. It's easy like that. Negative 1,500. Okay. So we already have. We have a what? A work done by friction, 1,500. So we say our work done by friction, which WF, is 1,000 negative 1,500. So we can say, okay, let's write aside all the information. Work done by friction is negative 1,500. So now we're going to say we have most of the information here. Excuse me. So we say now we are here, right? Remember, mass 200, gravity 9.8, and times height at C. We have height at C, which was what? 22 here, minus 88, because it was 88. We got it from the previous one. Now we can just simply substitute. So, okay. So now this work done by friction, we have negative 1,500. So the work done by engine equal to negative plus minus 1,500, because work done by friction equal to, okay, if you want, you can plug this, so you can write how it is, 200, and then I'll show you how to substitute. 22 minus 8.88. Okay, so what we can do now, we want to make subject what? Work done by engine. Work done by engine, we have to make the subjects. So work done by engine equal to, this is going to go over, so we're going to have equal to, it's going to become positive when it comes here, 1,500 joule plus 200 times 9.8. Okay, so what we're going to do now, we can plug that in the calculator. Okay, so I'm going to say 1,500 plus that one, and then we can work done by friction. You know how to plug in the calculator. If you plug in the calculator, that's going to give you, plug in the calculator value. It's going to give you 27. Plug it slowly. It's going to give you 27, 2, 1, 5, 20 joule. Oh, so this is work done by engine, but is not power delivered by engine. But we can get power delivered by engine. So work done, let me write here, work done by engine equal to 215.20 joule. So now we want to get power now. It's easy. If you have a work done, you can get power easy. Now we'll finish up now. Almost there, 1 second we'll be finished. Come on, erase here. Come on, you take your time, you can erase, man. Oh my God. Sometimes it does this computer, but I mean this pen here. I mean to say pen. Okay, so now we want to get what? Power. Power delivered by engine. How we get power? We say power equal to work done over time. But for now, is a work done by engine, which we have already. Equal to 27, 215, 215, 27, 215.20 joule over. How long did it take from B to C? We know. Come on, man. It was 15 seconds. Changing time, which is 15 seconds. Sometime, if they give you this time in minute or in hours, make sure you change it to seconds. Very important because most of the time they give you this stuff in minutes. So make sure you change the second. So now for that case, but now they give us in second, so we don't have to change. Plug in a calculator. So take it in a calculator. I'm sure you have plugs in the calculator, man. We're about to finish this. Let's plug now. Okay, plug in the calculator. Come here, quick. Okay, we come here and they say, okay, fraction. Now they say what? 27, 27. And after 27, you say 215, 215.2 20 second, and they come the denominator and then divide by what? By 15 seconds. And this is gonna give us an SD, plug in SD, so it'll give us 180, 14, 34.6666666666. So if you approximate, that's gonna be 30. What if you approximate that one? Is gonna be, man, we almost finished. So this is gonna be okay, so now let's go plug this quick. So this, if you approximate, this is going to be power of engine equal, okay, when you approximate, this is going to be 118.14. Remember, you get like 34.666666. So this is going to change. It's going to be 35. But remember, power you measure in watt. So that's how you do this question. It's very easy. Like I say, man, if you first time in this program, come here, subscribe, because every time I'm going to be uploading video on a regular basis. So all the students, I hope I respond to your question, distinction student, because we're doing getting 100%. Okay, we're not working getting 20 or 60. So this is easy. You thought it's hard? It's easy, man. So, I want to say shout again to all the students from KwaZulu Natal. I got a lot of love for you because you always send me questions. We're trying to help us with equation. That's why I'm doing this from deep down my heart. So if you come from a township, from rural, these programs for you, okay? These programs for you because I know it can be very, very challenging for you to have access to the quality, education, because of the structure of the education system, man. It kind of disadvantage to a lot of people who come from the rural or disadvantaged community. This is why I decided to do this, to give back to my brother and sister. See, my baby sister, my baby brother, all you my family. I love you from deep down my heart. So I do this. So if you get this video, don't keep it to yourself. Share to your friends. Share to your classmates. Share to the school. Share to all social media. Share to your friends. Share to your school. Everybody, so everybody can benefit. Because if you keep to yourself, and then means you become selfish, and it's not great. See, I'm not selfish, and that's why I give back. So when you see the brother like me who's giving back, you say, you know what? I also want to do it like Muchwana. I also want to give back to the community. I also want to inspire the community. So we can all do it. Thanks a lot for your time. I appreciate for your time. And Amandla, with peace. I'll see you very soon, right? Don't forget to click the like. You know why? When you like means it's going to reach more people. Listen, leave a comments, okay? Because when you leave a comments means I'm going to send shout out to you. I'm going to say, hey, Sibongile, Kumalo. Yabona. Lwazi, sawubona, molweni. You see? So I'm going to say shout out to everybody, man. You see? Kailebo. Peace. I'm out.